Good day, viewers. This is Ademola Johnson, your chemistry and biology tutor. You are welcome to today's edition of our series Stoichiometry. We have done stoichiometry of mass, we have done stoichiometry of volume. Now let's look at stoichiometry involving number of moles. Stoichiometry involving number of moles. Before we look at number of moles, what is mole? Mole is the amount of a substance. The amount of a substance which contains as many elementary entities as there are atoms in 12 grams of carbon 12. Mole is the amount of a substance which contains as many elementary entities as there are atoms in 12 grams of carbon 12. Now, the SI units of mole is still mole. The SI unit of mole is mole. Then there is what we call amounts. Amount in mole is also known as number of mole. Amount in mole or number of mole can be determined mathematically using any of the following formula. Now, the first one, which is the most popular one, is number of mole, which is N, is equal to reactive mass over molar mass. Or better still, number of mole equals to mass over molar mass. Number 2, that's number 1. Number 2, we can have number of mole. Number of mole equal to CV over 1000, where C is concentration. Concentration in mole per dm cube or in molar. Concentration in mole per dm cube or concentration in molar, capital letter M. So now, having gotten that, and V equal to volume in centimeter cube in cm raised to power 3. We can see our number of mole. Number of mole is equal to CV. This time there is no need for over 1000, where C is concentration. Concentration in mole per dm cube or molar. Concentration in molar or mole per dm cube. And V is volume, but now in decimeter cube. That is in dm raised to power 3. That is that. Then we can combine two of these things together. We have mass. Okay. That is when you are looking for mass. That's not necessary here. Okay. Do you know that number of mole? We still have number of mole is the same thing as volume over molar volume. So where molar volume is the volume occupied by 1 mole of any gas at STP, and it is equal to 22.4 dm cube, which is the same thing as 22,400 cm cube. Please, we have not changed any formula. It's still the same formula we were using. We started with mass concept, with volume concept. It's still the same formula we are using again. So stoichiometry is so interesting, very sweet. Once you just know this 4 set of formula, you are through. There is no problem anywhere. Let's begin to look at the example. The first example we want to look at now. Example 1. Example 1. We want to look at an example where our number of mole will be mass over molar mass. So we are going to be given a number that ends in small letter g, gram, and that number is going to be taken as mass. And we'll be given some parameters to find the molar mass. Then we don't divide it and get our answer. Let's look at the question. We are asked to find the number of mole of 5.2 gram of cacotiri. 2, 3.2 gram of nitrogen. Okay? Then the next one, number 3, 2.8 gram of sodium metal. Of nitrogen. Okay? So let's leave it at that. Then we will be given something like this. Calcium is 40, carbon is 12, oxygen is 16. Then we have nitrogen is 14, sodium is 23. Okay? We are given something like this. Solution to this. Number 1, our mass is what? 5.2 gram. Then molar mass of calcotiri. Calcium is what? 40. And we have only one calcium. We go to plus. Carbon is what? Carbon is 12. We have only one carbon in this formula. Plus oxygen is what? 16. But we have how many oxygen? 3 oxygen atoms. So we have 40 plus 12, that's 52. Plus, what is 16 times 3? That's 48. So if we add them together, 52, 48, 8, 9, 10, we have 0. We carry 1 here, that's 100. Okay? So that's 100 gram per mole. Okay. Now, then our formula now is what? Number of mole or amount in mole. Number of mole is equal to mass over molar mass. And what is the mass here? The mass here is 5.2 gram and the molar mass is 100. So let's press the calculator. Okay, I have 5.2 over 100. I have 0.052. Extra unit is what? Mole. Mole. So number 2, our mass is what? 3.2 gram. And molar mass of what? Molar mass of nitrogen is what? Is 14 times 2. Don't forget, you have to consider the atomicity of this element. Elements whose name end in gene, their atomicity is 2. So, which is 28 gram per mole. 28 gram per mole. So that is it. Now, our number of mole will now be equal to mass over molar mass. And our mass is what? 3.2. Molar mass is what? Is 28. So then we have 3.8 divided by 28. Answer is 0.14 mole. Then the third one here, our mass is what? Mass is what? 2.8 gram. Molar mass of sodium metal, which is sent as Na, is sent as what? 23 gram per mole. Iodine is 23. Here is 23. But the question is, uncle, here, why did you multiply 2? Why did you use 2 to multiply the 14 and you are not using 2 to multiply 23 years? Atomicity of any element whose name is ending in gene is 2. That's why the symbol of the formula for the molecule is N2. But any element whose name ends in ion, their atomicity is 1. So one molecule of that element contains 1 atom, which is the 23. So then, we now go yes. Our formula is still, you see what? Number of mole equals to mass over molar mass. So it says what's our mass here? Our mass is 2.8, molar mass is 23. So then we are having we now have 2.8 divided by 23. So our answer is 0.12 mole. Don't forget to always put SI units. Then let's look at another question, example 2, where we are going to be using another formula of number of moles. We have used number of mole equals to mass over molar mass. We still have number of mole equals to CV over 1000. Now, so here you are asked, find the number of mole of then of 2.5 dm³ of sulfur 4 oxide okay, then we are giving molar gas volume equals to 22.4 dm³. That's the question. Find the number of mole of 2.5 dm³ of sulfur 4 oxide. Now, what do we do? Solution to this: number of mole equals to volume over molar volume. Volume over molar. What's our volume here? Our volume here is what? 2.5. Molar volume has been given to be what? 22.4. And our answer is going to be be 2.5 divided by 22.4. Answer is 0.1112 mole. So that is that. Yes. Move on. What's number 2? You can be asked, find the number of mole of 182 cm³ of oxygen. Molar gas volume is equal to always 22.4 dm³. This one is, don't want to confuse you. Yes. By giving you what you have there, can you try something before we come to the board to help you out? Try something. Okay. Let me help. Yes. Our number of mole is equal to volume over molar volume. Yes. What's our volume here? 182 cm3. Although the molar volume given to you is 22.4 dm3, but this one must have the same volume as this. You now multiply this one by 1000. You have 22.4 times 1000 to convert to cm3. So we have 182 over 2 to 400. So that gives us 182 divided by 2 to 400. So we have 0.008 mole. That's what you have there. Now let's look at another one that we are going to use another formula entirely. Yes, remember? Okay, number 3. Find the number of mole of 0.5 molar of H2SO4 which dissolves in 250 cm3 of the solution. Find the number of mole of 0.5 molar of H2SO4 which dissolves in 250 cm3 of the solution. Now, our formula here is number of mole is equal to CV over 1000. Then what is our C? C is any number that carries molar in front or mole per dm3. Which is this? Our V is volume and any number that carries cm3 or dm3. But here is cm3, 250 cm3. We are true. So our number of mole now will now be 0.5 times 250 over 1000. So 250 here 1, 250 here 4. So we are left with 0.5 over 4. So we have 0.5 divided by 4. Answer is 0.125 mole. So that's how to do that. What you have given something like this. You are given something like this. Number 4. Find the number of mole of 0.08 mole per dm3 of HCl in 6.2 dm3 of the solution. Now, you will see that the volume will be given to you to be in dm3, unlike here that the volume is in cm3. So if the volume is in dm3, your formula is number of mole is equal to CV. No need for over 1000. So our C is any number that carries mole per dm3. So we have 0.08 mole per dm3. While our V is what? Is 6.2 dm3. So what do? We put in our values, then our number of mole will now be equal to CV. Our C is 0.08 times 6.2, and our answer is going to be 0.08 times 6.2, and the answer is 0.496 mole. So that is that. So we have gotten that. We have used three formula of number of mole here: mass over molar mass, volume over molar volume, then CV over 1000 and CV. So these are the various ways of calculating number of mole. So quickly, before our time runs up, let's look at number of particles or number of ions. That is what we are going to look at in our next video. So do watch out for our next video, where we are going to look at number of ions, number of particles, and so on and so forth. So we are stopping here. We are drawing the curtain here. Don't forget to subscribe. Don't forget to share this video. Don't forget to like this video. I remain my humble self, Afe Ademola Johnson. See you next time. God bless you, and bye for now. Thank you.
I love you, Daddy. How did you know?